Hello and welcome to the third episode of Teja Teaches. In this particular series, what I'm going to take you through, or what I have been taking you through in the first two videos as well, is some important concepts of quantitative ability in the first two videos. In this particular video, I am going to shift my topic or focus towards data interpretation and logical reasoning a little, because that is what a lot of people struggle with in the paper. And through this series of data interpretation of logical reasoning, DILR, I am my focus is not going to be too much on how to solve the set, because once you know how to solve the set, you will be able to solve the set, right? So I will not focus much on set solve kaise kare. I'll focus on how to represent data for different types of sets, because that is probably one of the most challenging parts of the question. Once you represent the data correctly, more often than not, you'll probably get the answer correctly. The second thing that I'm going to focus on, or should I not pick a particular set in the paper, whether that set is good enough for me to solve, how do you make that judgment? So I'll share with you my little framework. And there are certain set of rules for me, using which I choose a particular set or don't. So let's get started. So yeah, so must do sets for DILR, and today for this video we have chosen a set from set theory, and this is a CAT 2020 slot 1 set. So let's see what is in store. So first of all, to begin with, DILR, there is a dilemma whether I am familiar with a particular set or not. Then what is the level of complexity of a particular set? Boss, ये वाला set मेरे को पता तो है, but मेरे को ये भी पता है, I also know, along with knowing how to solve the set, I also know that this is probably going to take a lot of time. Then it's a no-go. The flip side is that I know how to solve the set and it is going to be easier, or I can guess that I should probably be able to solve that question in 10 minutes or 12 minutes. Then yes, it is a go kind of a question, pick me kind of a question. Otherwise it is not a pick me kind of a question. So the two things that mainly fall into this is familiarity and complexity. Familiarity comes obviously with practice. Complexity of the set is what you have to judge for yourself, because I'm telling you, complexity is not sacrosanct for everyone. Complexity is not sacrosanct for everyone. Complexity is very, very subjective. There may be a kind of set, which a kind of data that I may find very complex, but you may find it otherwise. So what may work for you may not work for me, what may work for me may not work for you. You have to figure out whether the set is complex for you or not. So if the familiarity is low, complexity seems to be high. That is obvious, because if you don't know how to solve that question, then probably you will feel that the question is complex. Okay, there is a possibility that the familiarity is low and complexity is also low, but I'll eliminate this possibility right away, that because if you don't know how to solve the question, kaise pata ki kitna complex hai, right? Then the familiarity is high and the complexity is low. Definitely solve. The familiarity is high, complexity is probably high. This is also almost solved kind of a question, but this low high and low is something that I will probably not touch, because I don't know how to solve that question, right? So wherever the familiarity is high, irrespective of complexity is low or high, I'll probably choose to solve that question. I may not choose to solve that question immediately. I may want to keep that set for the last 10 minutes of the paper or last 15 minutes of the paper if the complexity is high. The other part is, should I or should I not pick a set? The should I or should I not pick a set is a function of the familiarity and complexity of the set itself. What do I mean by complexity? For example, there is an initial setup of 3 lines or 5 lines or 7 lines, 5 lines to 7 lines. Okay, there is an initial setup of the question. Then there are some data points. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points, right? And then there are questions. Now questions can be two types. There can be an if question or a definite answer question, right? Even in this options wale question, there may be a choice called there may be a choice called cannot be determined. Again, that is not my friend, right? And then there will be theta. What I choose is If a set has typically theta questions, let us say 4 out of 6 questions in a set are theta questions. That means 4 out of 6 questions in a set are theta questions. It is giving me a clear indication. It is giving me a clear indication ki boss, set bana lo. You represent the data correctly. You should be able to answer all these questions, because cannot be determined or may be possible. If kind of things are not possible in theta questions, so theta questions hai agar majority of the questions following a particular set are theta questions, type in the answer, non MCQ questions, then probably that is the kind of set I would want to solve. The second is, it now depends on how is the setup and how is the data point, how are the data points. If the setup is 5 to 7 lines, okay fine, I'll read through the setup first. The setup doesn't mean anything to me. I look at what are the data points. See, if I have to solve if questions, my limit of number of data points would be 5 to 6, because I have to assimilate 5 to 6 data points, and for every question I have to form a different case. That is fine for me. But if there are 10 points, data points that I have to assimilate, and even after that there is an if kind of a question, then I will probably not solve that question. Similarly, up to 7 to 8 points for definite answer question is what I can assimilate. Anything that goes beyond typically 8 points, 10 points assimilate karke put it on the table. Boss, I am thinking of per one point, I'll probably take 1 minute to read, understand, and figure out where it goes in the table. So 10 points itself is 10 minutes. So I don't want to solve typically a question that takes, first 2-3 minutes I take and understand the setup, and then again 10 points, 10 minutes. So in the first 10-13 minutes in the set, I haven't even read the questions. In the first 13 minutes of the set, I am still not able to get one 3-mark question also correct, then that is probably a no-go kind of a question. So up to 7 to 8 points is fine. Anything beyond 9 to 10 points is, and above, is too much to interpret, or too much to comprehend for me, and I would typically leave that question. Now this is something that I follow. This, the same may not be true for you. You have to figure out what works for you. You try this. If it works out for you, it works for you. If it doesn't work, you have to figure out something else for yourself. All right, having said that, let's get started with set theory, representation of data. Right, so set theory, representation of data kind of questions, the questions that can be formed using Venn diagrams, you will typically find in exams like SNAP or NMAT or TISNET. You will typically find two sets, right? In exams like CAT or ZAT, you may find three set Venn diagram. Or again, in exams like CAT, ZAT, or not ZAT, CAT or IFT or MyCAT kind of papers, you may typically also find 4-set Venn diagram. The problem is, when it is a 2-set Venn diagram or a 3-set Venn diagram, the people find it very, very easy to solve because they know how to represent that data. The point is, starting point in a 4-set Venn diagram is how to draw that diagram, and some people struggle there, and that is why people leave that questions. But typically, if I look at 2-set, 3-set, and 4-set Venn diagram questions, typically the 4-set Venn diagram questions are the easiest of the lot. Now let us look at how to represent data in each of the sets. So if there are two sets in a questions, let us say in a class of 100 students, physics is taken by 70 students and chemistry is taken by 80 students. Physics is taken by 70 students and chemistry is taken by 80 students. So I'll draw two circles like this. The first circle represents physics and the second circle represents chemistry. I know the total number of people in physics is 70, total number of people in chemistry is 80. Now inside this, what is there is very, very important. So if you have two sets, how many areas do you have? For all we know, the visible areas are 3, but please understand there exists a universal set. There exists a universal set. So there are 4 areas, and this is how I go about the nomenclature so that I don't get confused ever in life. I say this is A, this is B, this is C, and this is D. So what is A? Only physics. What is B? Only chemistry. What is C? Area C? C is both. And D is none, is a very important factor. D is none is very important factor, because it may or may not be present in the question, but it is always there in the diagram. You cannot assume that to be equal to 0 unless mentioned specifically. So this is how you typically form a two set Venn diagram, and you keep giving values to A, B, C, D. Now what happens typically over here is, if this is C, this is also 70 minus C. A is equal to 70 minus C and B is equal to 80 minus C. So everything can be written in terms of C, and C is the critical point over here. Let us say there is a three set Venn diagram question in which there are three subjects. Physics is chosen by 70 students, chemistry is chosen by 80 students, and math is chosen by 90 students. Okay. So you'll draw three circles. For three circles, you can clearly see there are 1, 2, 3, 4, 5, 6, 7 areas. Actually, there is an eighth area outside. So again, you will form the universal set. Again, you will form the universal set and say there are 8 areas. So if there are two sets, there are two square areas, 4 areas. And if there are three sets, there will be two cube areas. That means there are 8 areas, and these are the 8 areas that are there. And how I go about the nomenclature is, again, A, B, C is in that order. I name it A, B, C. A, B, C are only one. That means this is only physics, B is only chemistry, and C is only math, right? Then I go and name areas which have exactly two, overlap of exactly two, both physics and chemistry, but not math. D, E, F. Then G is all three, and H is the one that is left outside. So these are the 8 areas, and this is how I go systematically about the nomenclature so that I don't get confused ever. Okay, I have set these rules for myself. Now let us say that there are 4 sets. How to go about a 4 set Venn diagram? How to represent data in a 4 set Venn diagram? We have physics, chemistry, let us say math is 90, and bio is another 80. So how to go about drawing a 4 set Venn diagram? So this is how you start. First of all, if there are 4 sets, how many areas should be there? 2 power 4, 16 areas should be there. So if I have to represent these areas by letters, I should be able to use 16 letters from A to P. From A to P, these are the 16 letters that I am going to use. So how to go about this? First of all, draw a 3 by 3 matrix like this. Let me do it a little better. First of all, draw a 3 by 3 matrix like this. So this is a square. इसमें 3 by 3 के छोटे छोटे squares. So these are 9 areas clearly, right? Now join this end and this end, this end and this end, this end and this end, and this end and this end. So now count the total number of areas within the diagram. There are 15 such areas, and there will be one outside which belongs to none. So to say, what happens is, this is the Venn diagram of physics. Every Venn diagram will look like this. This is the entirety of physics. This is the entirety of physics. So within physics, there is 1, 2, 3, 4, 5, 6, 7, 8 areas. 1, 2, 3, 4, 5, 6, 7, 8 areas are there within physics. Similarly, this is chemistry, this is math, and this is bio. And how do I go about naming them? I first check what are the areas that correspond to only one of the subjects, only physics, only chemistry, only math, and only bio. And I say this is A, this is B, this is C, and this is D. Ho gaya? Done. Now, how many such intersections will be there, or how many intersections will be there which will be a part of exactly 2 out of the 4 sets? You have a total of 4 sets. If you select any 2, 4C2, there should be 6 areas which are intersection of exactly 4, exactly 2 out of the 4 sets. Those 4 areas, those 6 areas, I'll start naming from D to J. So this is D, sorry, this is E, this is F. This area is a part of only physics and math, G. This is only chemistry and math, H. This is only physics and bio, I, and this is only bio and chemistry, J. So E, F, G, H, I, J. These are the 6 areas that represent an overlap of exactly 2. Now there is an overlap of exactly 3 happening in these 3 places, in 4 places, K, L, M, and N. And the area in between, O, is all 4. N is exactly 3, H is exactly 2, and A, B, C, D are exactly 1. So this is how you represent data in a 4-set Venn diagram. Once you are done with that, once you know how to represent the data, 4-set Venn diagrams are one of the simplest of the questions to solve. And let us take a look at this particular set. This is a set from CAT 2020 slot 1. Let us read the setup and check. 1,000 patients currently suffering from a disease were selected to study the effectiveness of treatment of 4 different types of medicines, A, B, C, D. So there are 4 different types of medicines, A, B, C, D. These patients were first randomly assigned to 2 control groups of equal size. Equal size, called the treatment group and control group. So there are 2 groups of equal size. So there is a treatment group which should have 500 people, and there is a control group which should have 500 people, right? Because they are divided into equal sizes. The patients in the control group were not treated with any of these medicines. Control group को तो कुछ दिया ही नहीं. Instead, they were given some dummy medicine called placebo containing only sugar and starch. हटाओ. Control group is out of the scope of the question. Whatever is in the scope of the question has to be treatment group now. The following information is known about the patients in the treatment group. All these points A, B, C, D, E, F pertain to 500 people in the treatment group. A total of 250 patients were treated with type A medicine, 210 with type C medicine, 25 patients with type A medicine only, 20 patients with type C medicine only. So this is giving me, देखो जब पेपर में क्वेश्चन आएगा बोल के नहीं आएगा सेट थियरी का क्वेश्चन है, it won't tell you that I am coming from set theory, but you need to understand when you look at these kind of points, only this is a total. That means there is some intersection happening. There is some only one, exactly 2 kind of areas that are there. And then you have to judge there are 4 different kinds of vaccinations. So it may very well be a 4-set Venn diagram question. So let us draw A, B, C, D ka Venn diagram. Let us draw A, B, C, D ka Venn diagram and start putting values into it. This is A, this is B, this is C, and this is D. A, B, C, and D. Now let us take a look at what are the data points we know. A total of 250 patients were treated with type A medicine. 250 patients were treated with type A medicine. A total of 210 patients were treated with type C medicine. Type C total, Venn diagram of C should have 210 people. 25 patients were treated with A medicine only. Now let me name them A, B, C, D, E, F, G, H, I, J, K, L, M, and O are the areas that I have. 25 patients were treated with type A medicine only. Type A medicine only is area A. Type A medicine only is area A. So area A में तुम्हारे पास 25 people are there. Okay. 20 people were treated with type C medicine only. 20 in type C only. 10 patients were treated with type D medicine only. 10 patients were treated with type D medicine only, right? 35 patients were treated with type A and type D medicines only. Only A and D, intersection of only A and D is I. So this is 35. I have completely used statement 1, completely used statement 2. Statement 3 I have used up to this point. 20 patients were treated with type A and type B medicines only. Only A and B. Intersection of only A and B is this area E. E corresponds to 20 patients. There are 20 patients here. 30 patients were treated with A and C only. A and C only is an intersection of A and C only is G. G is 30. 20 patients were treated with type C and type D medicines only. 20 patients were treated with type C and type D medicines only. So this is again 20. Area F corresponds to a value of 20. So I have completely made use of point C as well. Point D, 100 patients were treated with exactly 3 types of medicines. Exactly 3 is what areas? K plus L plus M plus N is equal to 100. Let's keep it aside. I've used this, but I haven't been able to deduce anything about KLMN. Let us see where it comes to picture. 40 patients were treated with medicines of type A, B, and C, but not type D. A, B, and C. A, B, and C, intersection of A, B, and C, and not D is area K. So this is 40. K is 40. Right? 20 patients were treated with medicines of A, C, and D, but not B. A, C, and D, but not B. A, C, and D, but not B. That is L. This is 20. L must be equal to 20. L must be equal to 20. 50 patients were given all 4 types of medicines. 50 patients were given all 4 types of medicines. So if 50 patients were given all 4 types of medicines, O is 50, and 75 patients were treated with exactly 1 type of medicine. Exactly 1 is what? A plus B plus C plus D should be equal to 75, out of which I know the value of A is 25, B I don't know, C is 20, and D is another 10. 25 plus 20 plus 10, we are done with what? 55. So B must be 20 as well. So B must be 20. I have put that down. B must be 20. I have put that down. Now, what are the areas that are unknown to us? What are the areas that are unknown to us? M, J, H, N, and C. Sorry, C is already known. M, J, H, and N. Only 4 areas are unknown to us. Let us take a look at the questions. How many patients were treated with medicine type B? To find how many patients were treated with medicine type B, we need to find H, J, N, and M. And but is that really necessary? Is that really necessary? Let us look at how could we be smart over here. Let us look at B. This is the Venn diagram of B. We know that 500 people have to be there in the entire Venn diagram. 500 people have to be there in the entire Venn diagram. So whatever is outside B, if I subtract 500 minus not B, B bar should give me B, no? Whatever is outside B, if I subtract, do I know all values outside B? Yes, I know. So I should be able to solve that question using that. So 25 plus 35, 60 plus 30 plus 20, 25 plus 30 plus 20 plus 35, 60 plus 50, 110 plus 20, 130 plus 20, 150 plus 10, 160 are outside. So B, number of people receiving vaccines from B should be 340 ideally. Okay. What other questions are they asking? Number of patients who were treated with B, C, and D but not type A. B, C, and D but not type A is N. N is what is the question? Okay. How many patients were treated with medicine types B and D only? B and D only is J. J is one more unknown. The number of patients who were treated with type D medicine. Type D medicine के लिए whatever is inside D. So we need N, M, and J. We need N, M, and J. So let us figure out how can we solve for all of these values. Now I know one thing for sure, that inside the Venn diagram of A, there should be 250 people, and inside the Venn diagram of A, there is only M, which is unknown. There's only area M, which is unknown. So using that, we can figure out how much is M. So 25 plus 30 plus 20 plus 35 is 110, 130, 170, 170 plus 20, 220, 220. That means M must be equal to 30. So M must be equal to 30. M must be equal to 30. The moment M is equal to 30 in this equation, N must be equal to 10. N must be equal to 10. N must be equal to 10. Now let us look at C. C has a total of 210 people. The only unknown value in C is H. The only unknown value in C is H. So let us see how much that should be? 20 plus 30 plus 40 plus 10, 100 plus 20 plus 50, 170 plus 20, 190. So h must be another 20. H must be another 20. That's it. H must be another 20. So once we have figured out h is another 20, h is another 20, the only thing that is left is j. The only thing that is left is j. We know that inside this entire Venn diagram, there have to be 500 patients. Inside this entire Venn diagram, there have to be 500 patients. A itself is 250. So everything outside A should add up to 250. Everything outside A should add up to 250. So if everything outside A adds up to 250, we have 20 plus 20 plus 20, 60 plus 20, 80 plus 100. So J must be equal to a huge value which is equal to 150. J must be equal to a huge value which is equal to 150, and we have hence determined each and everything that is required. Each and everything that is required to be able to solve that questions, any of these questions. So how many patients were treated with medicine type B? We already know the answer is 340. The number of patients who were treated with medicines B, C and D but not A, B, C and D but not A is N. 10. How many patients were treated with medicine types B and D only? B and D only is H. J, which is 150. And the number of patients who were treated with medicine type D was how much? Medicine type D is how much is the question. Everything outside D we can remove, or we can calculate whatever is inside D. So 50 plus 20 plus 20 plus 10, 100 plus 150, 250 plus 40, 290 plus 35, 325 must be the total number of people who were treated with D. 325 must be the total number of people who were treated with D. Going back to my philosophy of theta, look at this. All four questions following this were theta. All four questions following this was theta. The moment it is theta, it gives me an indication कि boss set ढंग से बना ले. You arrange the data correctly, you should be able to solve that question, and that is exactly what I have done. So represent the data correctly and you win. That's it. That's what is required in DILR. You learn how to represent the data, you have already won half the battle in any set of DILR.